Welcome, curious minds, to another deep dive. Imagine a world where building a skyscraper felt less like this monumental, multi-year thing locked into an unchangeable blueprint, you know, and more like crafting a dynamic, responsive app, fast, flexible, constantly adapting.
Mm.
Sounds a bit like science fiction, right? Well, today we're plunging into a truly fascinating question. Can the principles of Agile, born in the lightning-fast, iterative world of software development, truly take root and, well, flourish in the concrete, steel, and often glacial pace of construction?
Yeah, it's a real collision of worlds.
Definitely. And the stakes couldn't be higher.
It's more than just an interesting thought experiment, though. It's a fundamental challenge to traditional paradigms, truly.
Yeah.
What's utterly fascinating here is that we're not merely discussing, incremental tweaks to existing processes.
Right.
We're examining a potential philosophical shift in how we conceive, design, and build our physical environment. And this is driven by both aspiration for efficiency and, frankly, the sheer necessity of adapting to an unpredictable future.
So for you, our curious listener, this deep dive is a shortcut. A way to understand one of the most exciting and, let's be honest, most contentious debates shaping modern project management today. Okay, and to navigate this complex terrain, we've gathered an incredible stack of sources. We'll be pulling insights from classic architectural critiques, like those by Rayner Banham, and contrasting them with, say, Le Corbusier's grand, often quite rigid visions. We'll delve into the practical realities laid out in building codes, explore the deep dives into lean construction with its last planner system, and dissect the Project Management Institute's latest guidance.
And we'll also uncover the transformative power of building information, modeling BIM, glean insights from the theory of constraints, and revisit historical lessons. Think engineering giants like Isambard Kingdom Brunel, alongside the contrasting urban planning philosophies of Jane Jacobs and Robert Moses. A real mix. Our mission today, then, is to unpack this complex debate thoroughly. We'll explore both the tantalizing possibilities, where these iterative methods might offer significant advantages and deliver unforeseen value. Okay. And crucially, the immovable realities of construction, where Agile might become, frankly, a dangerous distraction from necessary foresight.
That's a vital point.
Yeah, we want to identify the sweet spot, the areas where construction can genuinely leverage an Agile mindset and where it just can't.
That's a stark warning and a vital distinction we need to make. So let's unpack this. So for many of us, the term Agile immediately conjures images of sprints and stand-ups from the tech world, quick meetings, short cycles. But if we strip away that jargon, what are the foundational ideas that first emerged from that lightning-fast development environment?
Right.
And how are major project management bodies now defining and advocating for these principles? What's the true core of Agile, really?
You've hit on the critical point. The essence of Agile goes far beyond specific ceremonies like stand-ups. At its heart, Agile is about adaptability over rigid, upfront planning. It's a recognition that projects are inherently complex and involve a great deal of uncertainty. And this isn't just a niche tech industry concept anymore. The PMBO Guide, the project management body of knowledge, which is, a global standard, has undergone a significant philosophical shift since around 2012.
Oh, really?
Yeah, it's moved away from being a prescriptive, process-oriented standard, telling you exactly how to do things, step by step, towards one that actually requires reflection to apply in practice.
Reflection.
Exactly. This principle-based format encourages adaptation, critical thinking, and tailored approaches from project practitioners themselves. It's a formal acknowledgement that projects, by their very nature, demand dynamic, responsive strategies, not just adherence to some fixed playbook.
That sounds like a radical departure from the traditional waterfall approach, where you'd spend months or even years planning every single detail before you even think about execution.
Oh, absolutely.
What are some of those key principles that the PMBO Guide is now championing that directly reflect this adaptive mindset?
Well, several principles are paramount for understanding this shift. First, there's transparency and open communication.
Okay.
And this isn't just about sharing information passively. It's about actively fostering an environment where all stakeholders, from the client to the on-site crew, can raise concerns, flag issues, provide feedback without fear of penalty or, retribution.
Right, psychological safety.
Precisely.
Precisely.
It means genuinely open communication channels, which is absolutely crucial when things are constantly evolving and problems need to be surfaced early. Without that trust, an adaptive approach simply falls apart.
So it's not just about what tasks you complete, but how you cultivate a culture of safety and shared understanding. It almost sounds like a paradigm shift in how authority functions on a project. Does this de-emphasize the traditional top-down project manager role?
It certainly adjusts it.
Yeah.
Another crucial principle is leadership, but with a significant twist. It emphasizes vision, creativity, motivation, and empathy as traits that can be exhibited by anyone on the team, regardless of their official title or position.
Anyone?
Yeah.
Interesting.
Yes. It's about empowering individuals at all levels to influence towards desired outcomes, rather than relying solely on a designated leader. This de-emphasizes hierarchical control and truly empowers the entire team to drive success, fostering collective ownership.
That's powerful. Every team member becoming a leader in their own right, influencing the direction. Beyond those cultural shifts, what specific concepts does Agile introduce to manage the actual work in this more flexible way?
Within this framework, they also define specific terms that are foundational to Agile's iterative cycles. A time box is defined as a short, fixed period of time in which work is to be completed.
Ah, the sprint.
Essentially, yes. The genius of the time box is that it limits scope creep within that specific period. It forces tough decisions about what can truly be achieved and delivered, ensuring a predictable rhythm of value delivery. It's about small, manageable, focused bursts of work.
So instead of one huge, daunting deadline way off in the future, you have a series of shorter, more achievable commitments. That makes sense.
Exactly right. And tied to that is throughput, which is defined as the number of items passing through a process. They use a throughput chart to visually show accepted deliverables over time.
Okay, tracking progress.
But it shifts the focus dramatically. It moves away from individual activity efficiency, like how many hours one worker put in, to the overall flow and value delivery of the entire system.
Ah,
It's not just about keeping everyone busy, it's about ensuring that completed work truly moves the needle for the project, getting things done, not just started.
that throughput concept really resonates. Shifting from individual tasks to the entire system's output makes a lot of sense.
And it feels almost counterintuitive to how many subcontractors might traditionally operate, right? Where their individual output is maybe prioritized.
It can be, yes.
Are we saying Agile would fundamentally reshape contractual incentives in construction, pushing for collaborative flow over siloed efficiency metrics? That seems like a huge potential implication. It absolutely aims to, or at least encourages thinking in that direction. This shift suggests a universal applicability of certain ideas beyond just software, prompting us to ask, if the project management standard itself is advocating for reflection and principles rather than just rigid processes, how far can that extend?
Right.
Can these flexible principles truly apply to something as solid and physically bound as a building? That's the core question.
Now, before Agile became such a, ubiquitous buzzword, many in manufacturing and even early construction were exploring lean principles. This philosophy also focuses on efficiency and continuous improvement. How does lean relate to what we're now calling Agile? Was it a precursor or more of a companion that laid the groundwork?
Lean philosophy absolutely is both a critical precursor and a strong ongoing companion to Agile. They share a lot of DNA. It's all about continuously improving value delivery, systematically identifying and eliminating waste, and truly understanding the entire system.
Eliminating waste, that's key.
Definitely. And a prime example that's highly relevant to construction is the Last Planner System, or LPS. The Practitioner's Guide to Essential Lean Research describes LPS as a benchmark for production planning and control. What's important is that it focuses on fundamental functions, presuppositions, principles, and processes without being overly prescriptive.
So, flexible like Agile.
Yes, it actively encourages experimentation and adaptation to find the best way forward in any specific construction context. It's not a rigid set of rules, but a framework for continuous learning and improvement on site.
That sounds very much like the adaptable learning mindset that Agile champions. What are some of the key elements that make LPS so effective on a construction site? How does it actually work?
Well, LPS starts with meticulous task breakdown. Projects are systematically broken down into phases, then phases into processes, processes into operations, and operations into individual steps, sometimes all the way down to elemental motions.
Wow, that granular.
It can be. This provides an incredibly detailed structure for planning and, crucially, for identifying potential constraints and dependencies at every single level. For example, the substructure phase might include the place drilled caissons process, which then breaks down into operations like fabricate cage, which further breaks into steps like fit and tack lifting bands.
Okay.
This level of detail isn't about rigidity. It's about clarity and foresight. seeing all the pieces.
So it's not just big picture, but also incredibly detailed in its decomposition. And yet this level of detail sounds like it could also become a rigid plan if not managed correctly. How does LPS balance this granular planning with the need for adaptability that Agile champions?
That's a crucial distinction, and where look-ahead planning is critical, this uses a short, rolling window, often something like 6 weeks, to proactively identify and remove constraints ahead of time.
6 weeks.
The goal isn't perfect prediction for the entire project, but rather to ensure that tasks scheduled for the immediate future are truly ready to be executed when planned. This minimizes surprises and delays on site. It means you're constantly looking slightly ahead, actively searching for potential roadblocks like material delivery or preceding work completion, and mitigating them before they can derail progress. It's active adjustment, not passive adherence to a long-range plan.
And how do teams ensure everyone is truly on the same page with these dynamic, frequently updated plans? Because communication breakdowns can be catastrophic in construction, as we know.
That's precisely where reliable promising, based on something called the language action cycle, comes in. This is a critical behavioral guideline for collaboration and accountability within these flexible plans.
Reliable promising. Okay.
It involves a clear sequence, making a request, negotiating and agreeing upon specific conditions of satisfaction, making a firm commitment, executing the work, declaring it complete, and finally declaring mutual satisfaction. It's about clear communication, explicit agreements, and mutual accountability within what is still a flexible planning framework. No assumptions.
So if a plumbing subcontractor requests access to a specific wall segment, it's not just an informal chat. It's a negotiation about when that wall will be ready, what condition it will be in, a clear commitment from the general contractor.
Exactly.
And then a mutual declaration of satisfaction once the work is done and verified. That level of explicit agreement seems absolutely crucial for avoiding miscommunications, blame games, and costly rework on a busy, interdependent site.
That's a fantastic real-world example of how it works, and linked to that is task definition. Tasks for daily or weekly work plans must be clearly defined: what, where, when, by whom, and easy to assess for completion. Crucially, they must be performable without incurring a penalty later.
Okay. No cutting corners now that creates problems later.
Right. This ensures that short-term actions are not just busy work, but are aligned with longer-term goals and don't inadvertently create future problems or rework. It's about making planning and execution more fluid and responsive, identifying potential roadblocks before they halt progress.
The PMBOK guide mentioned unanticipated consequences, and Lean and Agile both seem to be fundamentally about managing complexity. What does a systems view, looking at the project as a whole, bring to this discussion? How to connect all these moving, interdependent parts to truly grasp where Agile can make a difference?
This is where systems thinking becomes incredibly powerful and truly shifts our perspective. Thinking in Systems, the book by Donella Meadows, tells us that systems largely cause their own behavior. And surprisingly, systems with similar feedback structures produce similar dynamic behaviors, even if their outward appearances are completely dissimilar.
Really? Like what?
Think of a bustling construction site and a complex ecosystem. They can exhibit similar patterns of resource flow, bottlenecks, and adaptation. This suggests that principles for optimizing flow and managing complexity could be remarkably universal, transcending the specific industry. We're looking for underlying patterns, not just superficial differences.
That's a mind-bending idea that the underlying dynamics of seemingly unrelated systems can be so similar. It implies we can learn from entirely different domains.
Indeed. And building on this, the theory of constraints, TOC, as introduced in Eliyahu Goldrat's groundbreaking book, The Goal, offers incredibly concrete and directly applicable insights. TOC focuses on identifying and proactively managing the system's bottlenecks, which are the major constraints that limit overall throughput.
Right, the slowest part dictates the speed of the whole thing.
Exactly. And a key, almost counterintuitive insight is that the utilization of a non-bottleneck is not determined by its own potential, but by some other constraint in the system. Activating a resource, simply making it work, and truly utilizing a resource, making it contribute to the overall throughput, are not synonymous. You can be busy, but not productive for the system.
So let's say we have our most efficient drywall team, a non-bottleneck, installing sheets as fast as they can. But if the electricians, who are currently the bottleneck in the project, haven't finished their rough-ins in the next section, then those perfectly installed drywall sheets just sit there, adding no value to the finished project in the immediate term. It's like having a super fast chef making appetizers for a party, but the oven for the main course is broken. The appetizers just pile up.
That's a perfect analogy.
The real efficiency, then, must be in synchronizing everything with that slowest link, the bottleneck, to maximize overall flow.
That's it exactly. Inflating batch quantities, like ordering a huge amount of drywall for that fast team, or having the chef make too many appetizers to improve individual efficiency, actually creates excess inventory and waste, not greater throughput for the whole system.
Right.
The focus should always be on making bottlenecks work on parts that will directly contribute to immediate value delivery. It's a continuous process of ongoing improvement, identifying, exploiting, subordinating everything to, elevating, and then finding the next system constraint. It never stops.
Okay.
So we connect this to the bigger picture. We're looking at managing a building project as a truly complex system with interconnected flows, not just a linear sequence of isolated tasks. This holistic, dynamic view is crucial for truly understanding where Agile principles might make a difference.
Okay, so the theory sounds incredibly compelling. We've talked about Agile's adaptability, Lean's continuous improvement, and the power of systems thinking to optimize flow. But construction is fundamentally, viscerally different. It's physical. Once concrete is poured, you can't just hit undo or easily refactor like in code.
True.
So why are we even considering applying these iterative, flexible ideas to building things? What's the fundamental, perhaps even profound need that's driving this conversation? Is it just efficiency or something deeper?
You're absolutely right. The physical reality is undeniable, and we'll definitely delve into those constraints later. But the very nature of buildings themselves and how they interact with human life over time provides a compelling argument for adaptability. How Buildings Learn, a seminal work by Stuart Brand, provides a truly fascinating perspective here. It highlights that buildings aren't monolithic entities. They are composed of distinct systems, each changing at its own pace. Brand identifies 6 shearing layers: site, structure, skin, services, space plan, and stuff.
Shearing layers. Interesting name.
Yeah, and each of these layers changes at a vastly different rate. For example, the site changes very slowly, if at all, over centuries, while stuff, your furniture, decorations, personal tech changes constantly, perhaps even daily. Services like HVAC and electrical can change every 7-15 years, while the structure might last 3,300 years.
Here's where it gets really interesting. Because we're not just talking about managing a building project in an agile way, but seeing the buildings themselves as needing to be agile, needing to adapt. That's a profound conceptual leap. How does this perspective reshape our understanding of what a good building actually is?
Precisely. And truly adaptive building, according to Brand, must allow for slippage or independent movement between these different layers.
Okay.
If these systems are too tightly embedded or fixed together, a critical problem emerges. The slower changing systems block the flow and evolution of the quicker ones. Think about trying to rewire a building where the conduits are buried deep in concrete. Exactly. Conversely, constant change in the quick systems, like constantly upgrading technology or reconfiguring office space, can tear up and compromise the slower, more permanent layers, leading to destruction or rapid obsolescence over time. The source sharply criticizes designs that tightly embed systems like those slab-on-grade foundations, which bury pipes and remove vital space for future maintenance or expansion, making them inherently maladaptive and costly to modify just years down the line.
Right.
A good building, then, isn't just beautiful or structurally sound at day one. It's one that anticipates and accommodates change throughout its life.
And this need for adaptability means that what might seem like a perfectly designed, unchangeable masterpiece might actually be a disaster in the long run for its inhabitants, right? A monument to rigidity.
Absolutely. And this is where we see the striking contrast with some architectural icons. Frank Lloyd Wright, despite his undeniable genius, designed buildings that were, as Brand puts it, so totally designed that they cannot be changed. His famous falling water, celebrated globally, was, ironically, notoriously leaky and often unlivable for its original owner, the Kaufman family. They famously nicknamed it rising mildew, or a 7-bucket building, due to its persistent water ingress.
7 buckets. Not ideal.
Not ideal at all. The source states that for its leaks, there can be no excuse. The owners were effectively forced into the role of a curator of a Frank Lloyd Wright museum rather than inhabiting a functional home. This is a powerful counterexample to adaptable design, showing how a rigid, fixed vision, no matter how brilliant in concept, can utterly fail to accommodate the inevitable forces of use, climate, and the need for human comfort over time.
It seems like this push for adaptability extends beyond individual buildings to how we think about entire cities. If buildings themselves need to evolve, what about the larger urban fabric? Are cities also agile systems, or do they need to be?
Indeed, this adaptive philosophy extends directly to urban planning, contrasting sharply with modernist ideals. Jane Jacobs, in her groundbreaking work, The Death and Life of Great American Cities, famously critiqued rigid, top-down urban planning, particularly someone like Le Corbusier's City of Tomorrow.
Right, the big master plans.
Yeah, she described his sprawling antiseptic vision as a wonderful mechanical toy that tells nothing but lies about how a city truly works. She argued it failed to understand the organic, constantly evolving, and frankly, messy nature of vibrant urban life. She advocated passionately for diversity of uses, short blocks, and mixtures in building ages and types as crucial counterforces to the vacuums of deadness created by functionally homogeneous areas.
So she's arguing that a city needs that organic slippage too, that unpredictable bottom-up growth and diversity to truly thrive, rather than being imposed from above by a single master plan. And she famously valued the old, didn't she, against the constant urge for demolition and rebuilding.
Precisely. She powerfully argued that the economic value of old buildings is irreplaceable at will. It is created by time. This emphasizes building for longevity, flexibility, and adaptability, rather than fixed, single-purpose structures that quickly become obsolete or create those vacuums in the urban fabric. It's about allowing a city to learn, adapt, and evolve its functions over decades. And building on that idea, The City of Tomorrow, a more recent source, explores the emerging concept of smart cities, where sensor networks and data-driven feedback loops turn the entire urban space into a kind of reflexive test bed and workshop.
A city as a workshop.
Yeah, this futurecraft involves a fascinating merger of top-down strategic planning and bottom-up data-driven responsiveness, aiming for sustainable efficiency through a hybrid model with a measure of chaos.
So a city or even a building needs to be able to learn and evolve over time like an agile product, to constantly sense, respond, and adapt to its inhabitants and environment. That's quite a vision.
Absolutely. It's about creating sensible cities where optimization is inflected with humanization and architecture performs as living organisms, constantly adjusting and improving. This vision is deeply aligned with the agile notion of continuous adaptation and responsiveness, where real-time data and feedback drive evolution, not just a static initial design. It's about building in the very capacity for change and learning from the very beginning, seeing the city as an ongoing, iterative project.
Beyond just this profound need for adaptability, what else makes an agile mindset attractive to construction? What other benefits does this philosophy offer, especially when we consider perennial challenges like problem solving and collaboration on complex projects?
Well, the idea of constantly responding to new problems with innovative tools and solutions isn't actually new at all in architecture or engineering. Rainer Banham, a visionary architectural critic, frequently explored how technology and consumer culture shaped architecture, emphasizing themes of flexibility, expendability, and systems. He was thinking about this stuff decades ago. And Le Corbusier, even back towards a new architecture, observed how quickly industrial tools and technologies had transformed in his era, leaving the human animal breathless and panting, trying to keep up.
Breathless and panting. Good description.
Isn't it? This speaks to a continuous, almost inherent human need for social R&D and innovation, which Peter Drucker also suggested in management tasks, responsibilities, practices, advocating for decentralized organizations and a focus on ongoing improvement. Agile, at its core, formalizes and institutionalizes this continuous problem-solving spirit, embedding it into the very fabric of the project.
So it's about embedding innovation and a problem-solving culture into the daily process, not just waiting for big, rare breakthroughs or relying on individual genius, making it systemic.
Exactly. And we see examples of this individual, creative, problem-solving spirit even in traditional construction figures. Frank Lloyd Wright's autobiography, for instance, details how perseverance and creativity can lead to innovative solutions, even when facing limited resources. He recounts a period during the construction of Taliesin where, after struggling immensely to acquire sufficient lumber due to financial constraints, he and his team resorted to logging their own timber from the surrounding Wisconsin land.
Wow, really? Logging their own wood?
Yeah. This embodies the inventive, problem-solving spirit central to Agile, where constraints become catalysts for innovation and adaptation. You figure it out.
That's a great historical anecdote that brings it to life. And what about the people involved, the clients, the builders, the designers? How does Agile's emphasis on continuous customer collaboration translate into the construction world, especially given how client needs can shift, sometimes dramatically?
That's a crucial point, and it's something that naturally arises in complex custom projects anyway. Tracy Kidder's house provides compelling anecdotal evidence of the intense, often evolving client-builder relationship in custom home design. He described how initial plans were often sketchy, and the imagined house began to change as the clients and builders engaged deeply throughout the process.
As they saw it take shape.
Exactly. The clients would, as he beautifully puts it, populate the bare rooms of the house with visions of the life in them to come. And those visions naturally evolved as the physical structure began to emerge. This vividly highlights the inherent importance of continuous collaboration and adapting to client desires, which often evolve as the project progresses and they can physically experience their emerging space. Agile recognizes this fundamental human reality and builds formal mechanisms to incorporate that evolving feedback, rather than fighting against it or treating changes as purely an unwelcome, costly change order.
So, if adaptability, creative problem solving, and continuous client collaboration are keys to unlocking value in construction, what practical tools and specific adaptations are helping the industry actually embrace this more agile mindset? It can't all just be philosophical concepts, right? There must be tech involved.
You're absolutely right. Theory needs practical, powerful application. And building information modeling, BIM, is a prime example of a technology that acts as an incredibly powerful agile enabler in construction.
Ah, BIM. We hear a lot about that.
Yeah, and for good reason. The BIM handbook describes it not just as a static 3D modeling tool, but as a dynamic process that generates a rich database of information. And it's designed to be shared with other applications for early feasibility studies and, crucially, for intense real-time collaboration among all project stakeholders.
So a shared digital space.
Exactly. This is vital for Agile, as it inherently supports interoperability and open data exchange standards, allowing diverse teams, architects, engineers, contractors, even clients to work together seamlessly on a shared digital model, breaking down silos.
So BIM creates a living, evolving digital blueprint that everyone can interact with and contribute to. How does that translate directly to iterative design, where changes are expected, even welcomed?
It's transformative because it fundamentally changes the design process. BIM applications now include sophisticated concept-level design exploration tools that utilize things like mass or proxy objects.
Okay.
These can be parametrically customized, allowing for free-form edit operations and rapid prototyping of shapes, volumes, and even the skins or facades of buildings. Think of software like Revit 2011, ArchiCAD, Vectorworks, or Bentley Architecture's generative components. They enable designers to quickly iterate on virtual models, test countless different forms, analyze their performance, and refine ideas without the immense cost and time required for physical mock-ups or repeated 2D drawing revisions.
Right, much faster feedback.
Much faster. This provides critical, rapid feedback loops in the design phase, bringing agility to an area traditionally slow and linear.
So instead of waiting for finalized blueprints that are then sort of set in stone, designers can iterate on virtual models. And those changes are immediately reflected in material lists, costs, and even energy performance data. That's a huge shift from sequential design to a truly iterative process.
Precisely. Project management in construction explicitly notes that CAD systems like Autodesk Revit are data-based to produce bill of quantity lists of materials and 3D models, with any change in design reflected in a change of the list of building materials and the 3D model. This rapid, integrated feedback loop is a cornerstone of an agile design approach.
Makes sense.
Furthermore, BIM significantly facilitates integrated project delivery, IPD. This is a contractual arrangement that integrates main project participants, owner, architect, general contractor from the very beginning, sharing risk and reward.
IPD. Heard of that too.
And it aligns perfectly with Agile's emphasis on co-located, cross-functional teams and early continuous collaboration, moving away from potentially adversarial relationships toward shared goals and risks.
Okay, so that covers the digital realm of BIM. But how are construction teams physically adapting the lean and agile mindset on site? What concrete, pun intended, methods are being used in practice to bring this iterative thinking to the actual building process?
On the ground, teams are actively implementing several lean construction methods that embody agile principles. For example, the CMAA Construction Management Standards of Practice describe the short-term construction activity plan.
Okay.
This is essentially a rolling schedule developed maybe week by week, or what's also known as a look-ahead schedule. It's a pragmatic adaptation of iterative planning. It allows teams to respond to immediate site conditions, unforeseen challenges, and recover schedule slippages much faster than a rigid, fixed master schedule would ever permit. It's about constant adjustment based on real-time feedback from the site.
So it's about smaller, more frequent adjustments to a dynamic plan rather than trying to perfectly predict everything months or even years in advance and then penalizing any deviation. That seems far more realistic for a complex site, doesn't it?
Exactly. It embraces reality. And central to making this work is the concept of reliable commitments, which we discussed earlier from the Practitioner's Guide to Essential Lean Research. That language action cycle, with its focus on clear requests, negotiations, and explicit commitments.
Right. The reliable promising.
Yes. It ensures that even as plans evolve in these rolling schedules, everyone involved understands their immediate responsibilities and accountabilities. It's about fostering trust and predictability through making and keeping short-term commitments that align with the longer-term project goals. This isn't just adding bureaucracy, it's about building shared understanding and accountability in a dynamic environment.
That makes perfect sense. What about managing the inevitable unknowns, the risks and the problems that just happen on any construction site? How do these adaptive methods handle that, especially when traditional risk management can sometimes feel very reactive, like putting out fires?
That's where robust risk management comes in, as meticulously detailed in the CMAA standards. It's a structured, proactive process that aligns really well with iterative thinking. It involves identifying potential risks, thoroughly assessing their impacts, developing comprehensive mitigation and contingency plans before they become full-blown crises.
Planning for the worst, hoping for the best.
Sort of, yes. And then continuously tracking, communicating, and resolving those risks throughout the project lifecycle. This continuous feedback loop is absolutely essential in an adaptive environment where you're not just executing a fixed plan, but constantly navigating emerging challenges. It's proactive and iterative, much like an agile sprint review might be, but focused specifically on potential project pitfalls and ensuring resilience.
What's fascinating here is even the broader push for sustainability in construction seems to align quite strongly with some core Agile principles. It's not just about efficiency during the build, but also about long-term thinking, adaptability, and value over the entire life cycle of a building. Is that a fair connection?
Yes, I think there's a profound connection there. Sustainable construction highlights design for the environment, DFE, which advocates for greater effort during the design phase to ensure the recovery, reuse, and/or recycling of the product's components.
Designing for disassembly.
Exactly. It goes even further, suggesting that entire buildings should be designed to be taken apart or deconstructed. This concept of front-loaded design for adaptability over the building's entire life cycle, not just its initial construction, aligns perfectly with Agile's long-term value perspective and its emphasis on considering the future impacts and mutability of current decisions.
So instead of designing a building to be permanent and fixed, we're designing it to be mutable, almost like a complex, long-lived product that can be upgraded, repurposed, or even gracefully disassembled. That's a fundamentally different way of thinking about building permanence.
Precisely. And this is where the Agile value of continuous stakeholder engagement becomes critical again. The source points out the unfortunate risk of sustainability goals being value engineered out of a project when cost pressures inevitably mount later in the process.
Yeah, that happens.
It does. This reinforces the need for continuous buy-in, transparent communication, and unwavering alignment from all stakeholders, much like how Agile teams keep the customer intimately involved throughout development to ensure value delivery. If sustainability is a core value, it needs to be championed, tracked, and integrated throughout the entire iterative process, not just treated as a nice-to-have at the beginning that gets dropped later.
This all sounds incredibly promising, offering a pathway to more responsive, sustainable, and collaborative construction. But let's be real, we have to address the elephant in the room. Building a foundation isn't like writing a line of code you can easily delete, refactor, or roll back.
Not at all.
Where does Agile hit a wall? What are the unyielding realities that make construction fundamentally, perhaps irreconcilably, different from software development?
That's the critical counterpoint, and it brings us to a crucial consideration: the fundamental, undeniable difference between the digital and physical worlds. Unlike software, which exists in a virtual space, construction is governed by a dense web of prescriptive, often rigid, regulations and immutable physical laws. Building Codes Illustrated makes this abundantly clear.
Right. The code.
You have strict, non-negotiable requirements for everything. occupancy groups, the use of non-combustible materials or mass timber, enclosed shafts for fire protection, automatic sprinklers, specific fire resistance ratings for structural elements, types I through V, and even precise wind load anchoring requirements. Many foundational decisions require conferring with the client and with the building official early in the design process to get concurrence.
And once you get that concurrence,
And once a foundation is poured or major structural element is cast, that decision is often irreversible without immense cost and effort.
you can't just roll back a building code violation or a structural mistake. The cost of changes must be astronomical, both in terms of money and time. It's not like fixing a bug in the next sprint.
Absolutely. The physical realities are truly unyielding. Fundamentals of building construction vividly illustrates this by explaining that a full height of a wall cannot be cast in one operation because the pressure of so great a depth of wet concrete would blow out the sides of the fragile forms.
You're right, the physics of it.
Exactly. Concrete pours must happen in several lifts of limited height, a physically dictated sequence that cannot be arbitrarily changed by a project manager thinking iteratively. And if concrete strength tests are deficient, Fundamentals of Residential Construction explains that the contractor will be required to cut out the defective concrete and replace it. Yeah. The cost of changing a physical structure after it's built is orders of magnitude higher than rewriting software, incurring massive delays, immense labor costs, significant material waste, and often legal complications. This inherent irreversibility and the extraordinarily high cost of rework are arguably the most significant constraints on truly iterative, fail-fast changes in construction.
Construction also has centuries, millennia even, of tradition behind it, from ancient temples to towering cathedrals. Is there also a cultural or historical resistance to this kind of rapid, iterative change beyond just the physical constraints? A mindset deeply ingrained against constant adaptation.
Absolutely. The weight of tradition and a deeply ingrained culture of long-term fixed planning are significant factors. Consider the medieval cathedral builders, for instance. Their projects spanned generations.
Decades, centuries even.
Right. These were not agile sprints. They required meticulous, multi-generational long-term plans that might evolve slowly over decades or even centuries, but always with a grand, fixed vision at their core that could literally outlast human lifetimes. Similarly, 16th century mining techniques, meticulously detailed in George Agricola's De Re Metallica, illustrate fixed, painstaking processes that emphasize foresight, adherence to established methods, and minimizing error through rigid planning, given the dangers involved. These historical precedents reflect an industry fundamentally built on long-range vision and careful, predetermined execution.
And more recently, we've seen figures who epitomized that grand, master plan, top-down approach, almost battling against the very idea of organic change or iteration. Robert Moses comes to mind.
Indeed. Robert Moses, New York City's legendary power broker, epitomized the top-down long-range master plan approach. As Robert Caro's monumental biography, The Power Broker, describes, Moses had a grand vision for New York. He transformed abstract ideas into concrete and codified demands.
Concrete demands, literally.
Literally. He would leverage the expertise of engineers, landscape architects, draftsmen, not for iteration, but to firm up his ideas into specific demands, often using immense political power to push through his projects like bridges, highways, and housing developments, even when they led to significant financial obligations and eventually no money available for non-Moses projects in later years. This kind of monolithic, fixed planning, executed with unwavering resolve, clashes directly with Agile's iterative, emergent philosophy that values adaptability above all.
It sounds like there's a deeply built-in resistance to design changes once construction actually starts, often seen not as an opportunity but as a hindrance to progress and efficiency, a disruption.
Precisely. Fundamentals of Residential Construction notes that in AS-produced speculative work, the designer is rarely consulted after the drawings have been completed unless there is a serious problem, because, well, input by designers during the construction process only impedes progress and delays the schedule.
Wow, that's blunt.
It is. This clearly highlights a traditional mindset that views design changes during construction as a hindrance, not an opportunity for improvement or a valuable feedback loop. And then there's the contractual rigidity. Construction law reminds us that the works are generally a general, all-embracing description of the finished state defined up front.
Locked in the contract.
Pretty much. While changes are possible, they almost always involve formal change orders, with often contentious adjustments to contract price or time, or both. A process that can be slow, expensive, and adversarial. as discussed in the CMAA Construction Management Standards of Practice. This formal, often combative process for change is diametrically opposed to Agile's flexible, collaborative approach where change is expected.
Project management in construction mentions that construction has often been perceived as slow to embrace technology. Given all these deeply rooted factors, the physical constraints, the weight of tradition, the contractual rigidity, and the sheer scale, why do you think this label has stuck so stubbornly? What are the underlying reasons beyond the obvious?
Well, the perception stems from a confluence of interconnected factors unique to the industry. One major reason is its inherent complexity and fragmented nature. Construction projects involve numerous independent entities, owners, designers, general contractors, dozens of subcontractors, specialized suppliers, each with their own goals, processes, and often proprietary systems.
A lot of moving parts.
A huge number. The prevailing contractual models frequently create silos, where information isn't easily shared and true collaboration isn't inherently incentivized. This makes comprehensive, system-wide technological adoption difficult, as implementing new tech often requires cross-organizational buy-in that is just hard to achieve.
So it's not just about one company or one trade being slow, but the entire, often disjointed ecosystem of a project that makes change hard.
Exactly. And, as the goal so brilliantly illustrates, an overemphasis on individual efficiency within these silos, rather than optimizing for overall system throughput, can actually perpetuate inefficient practices. For example, a subcontractor might deliberately overorder materials to keep their crew busy and avoid idle time inflating batch quantities, as the source describes, which creates excess inventory for the overall project, hindering flow, increasing storage costs, and potentially leading to waste.
Right, the local optimization problem?
Exactly. This focus on local optimization rather than global throughput can actively prevent the adoption of integrated, system-wide technological solutions that prioritize the project as a whole.
And what about the human element, the actual craftspeople on the ground? Do they play a role in this resistance to new technology or rapid change, given the deep history of physical craft in the industry?
They absolutely do, and it's a critical consideration we shouldn't overlook. Matthew Crawford, in Shop Class's Soulcraft, points to the spirited man, who tends to act as though any material things he uses are, in some sense, properly his, and expresses a potential hostility to environments that break the direct connection between his will and his environment.
Interesting take.
It is. This can be interpreted as a potential resistance from skilled tradespeople to abstract, rapidly changing digital plans if they don't feel a sense of ownership, craftsmanship, or deep understanding of the process. If technology or rapid changes disconnect them from the tangible craft, the immediate feedback of their hands on materials, it can breed resistance. The industry has a proud history of physical craft, from medieval masons to modern trades, and shifting that mindset requires careful consideration of this fundamental human connection to the work. It's not just about processes, it's about people and pride in their skill.
So after this deep dive into both the compelling arguments for adaptability and the undeniable, unyielding realities of construction, what does this all mean for the industry? Can Agile truly be applied, or are we stuck with the old ways?
It sounds like we need to find a nuanced balance, doesn't it? A middle ground that respects both the innovative, flexible spirit of Agile and the inherent constraints of the physical world.
If we connect this to the bigger picture, the challenge isn't a binary choice between Agile and waterfall or traditional methods. That's really a false dilemma. It's about finding the appropriate level of agility for different phases and aspects of construction, creating intelligent hybrid approaches that leverage the strengths of each.
Hybrid approaches, okay.
Agile principles can truly shine in certain areas, particularly where the cost of change is lower, where complexity is high, and where iteration offers significant benefits in terms of exploration and learning.
Where do you see those areas being most effective? Where can construction really lean into an Agile mindset and see a tangible impact based on what we've discussed? The design phase is undoubtedly where Agile principles can truly shine, acting as a crucial front-loaded design stage. The pervasive use of BIM for concept-level design exploration and parametric customization allows for incredibly rapid prototyping, visualization, and intense feedback loops before anything is physically built.
Before the concrete gets poured.
Exactly. The challenge of sequencing decisions in early design before production of construction documents, as identified by the last planner system, is exactly what iterative design aims to address. You can explore multiple design options, quickly get stakeholder feedback, analyze performance characteristics, and refine the model much faster and cheaper than with traditional drawing sets. This iterative approach fosters greater creativity, innovation, and responsiveness to client needs right at the start.
So we can be highly agile in the virtual world before we commit to the physical reality, minimizing expensive surprises down the line. That sounds incredibly powerful and practical.
Precisely. And this extends to early stage planning and visioning. Think of Robert Moses's formidable ability to define specific demands, using the expertise of engineers, landscape architects, draftsmen. While his overall approach was rigid, the process of rigorously clarifying a clear vision and front-loading detailed design can be reframed as a front-loaded design phase that then prepares for more agile construction later.
Setting the stage.
Yes, the CMAA standards emphasize establishing BIM goals and objectives with owner alignment early on, and even using BIM experience as a selection criteria for the design team. This upfront clarity, enabled by digital tools, sets the stage for more adaptive, informed execution, even if the subsequent physical work is less agile in the pure software sense.
What about once we actually start building? Are there parts of the physical structure that can be more agile than others, or is it just the planning and design that benefits most?
No, definitely parts of the build, too. While core structure and foundations are largely irreversible, elements like the building's skin or services, HVAC, electrical, plumbing, data infrastructure, could benefit immensely from more adaptive approaches.
The faster changing layers.
Exactly, those faster shearing layers we talked about from how buildings learn. Designing these layers to be more modular, easily accessible, and independently upgradable allows for future changes and adaptations over the building's lifespan without tearing apart the entire structure. Think about how much easier it is to upgrade IT infrastructure if it's run in accessible raceways rather than buried in walls.
Makes sense.
And digital integration, like smart building management systems and smart thermostats that direct energy where and when needed, exemplify an agile, responsive service system that can continuously optimize performance based on real-time data and changing occupant needs.
So it's about making the changeable parts easy to change, even if the core is fixed. That allows a building to truly evolve and remain relevant over decades, rather than becoming obsolete quickly.
That's the essence of it, designing for longevity through adaptability. And finally, the underlying communication and collaboration frameworks derived from Lean and Agile are universally applicable and hugely beneficial across all project stages. The language action cycle of reliable promising from Lean construction, coupled with PMBOK's emphasis on a transparent working environment and open communication, provides a robust framework for managing evolving requirements and commitments. This framework can dramatically improve team dynamics, accountability, and problem solving, even within a largely traditional project structure. It's about managing expectations and commitments effectively, fostering trust, and ensuring everyone is pulling in the same direction towards a shared, evolving goal.
It sounds like Agile isn't necessarily about throwing out all plans and just winging it, which would be absolutely disastrous in construction.
Can't definitely time.
Instead, it's about making plans more flexible and responsive, particularly where the costs of change are lower and the benefits of adaptability are highest. It's about strategic agility, applying the right dose in the right place.
Precisely. It's about leveraging powerful technology like BIM for visualization and iteration in design, and then applying Lean principles on-site for managing workflow and constraints with short-term reliable commitments. It's an ongoing journey of adaptation and continuous improvement, carefully selecting the right tools and mindsets for the right phases and layers of a complex construction project. The goal is to build flexibility where it's possible and valuable while respecting the immovable realities where it's not, ultimately creating more resilient, user-centric, and sustainable structures. #tag outro.
What a journey we've taken. From the origins of Agile and software to the grand, often rigid visions of architects like Le Corbusier, the strictures of building codes, the historical precedents of engineering marvels like Brunel, and the profound adaptive needs of living buildings and cities. Wow. It's abundantly clear that applying Agile to construction is complex, challenging, but also incredibly promising. It is most definitely not a simple copy and paste job from tech.
We've thoroughly explored that success lies not in blindly copying software development methods, but in truly understanding the core principles: adaptability, continuous feedback, transparency, communication. Then it's about applying these principles strategically and intelligently where the physical realities and contractual frameworks allow and where they yield the greatest value. It fundamentally means shifting our mindset from a fixed blueprint to an evolving system, always asking, how can we deliver value faster, more responsively, and with greater long-term sustainability? It's a pragmatic, principle-driven approach tailored to the unique, demanding environment of the built world.
So what does this all mean for you, our listener, as you navigate the complex world of projects and development, maybe even your own home renovation?
Well, this brings us to a crucial final thought. In a world where every action creates data, where our cities are increasingly becoming sensible test beds for innovation, and where the pace of change seems only to accelerate, how might we design our next generation of buildings to be not just smart or technologically advanced, but truly wise?
Wise buildings.
Yeah.
I like that.
Capable of learning, evolving, and gracefully adapting long after the last brick is laid, adapting not only to their users' changing needs, but also to the inevitable, unpredictable future that awaits them. It's a profound challenge and an exciting opportunity, something for you to mull over until our next deep dive.
Until then, stay curious.